Good morning, everybody. I'm Vincenzo Croce from Ingegneria Informatica. I'm senior researcher and project manager at the R&D laboratory, and I'm going to give you this short overview introduction to the eDREAM project. The project is a 3 years project. It's a research and innovation action, and started in 2018 and now is going to finish in this June. So we are quite close to the end of the project. Engineering is the coordinator, and the different countries involved are Italy, Greece, Romania, Spain, and UK. Different stakeholders, different partners take part to this collaboration, and we have a wide relevant range of players that include the ICT player and like engineering, Atos, and the energy at work. Then different kind of energy stakeholder, including us, Terni, that is DSO of Terni area, aggregator are Emotion and Kiwi, and as a servlet it is an ESCO. And also we have academic research contributors that list the Teesside University, Cluj-Napoca University, and CERT is a research center located in Greece. The content and the context where eDREAM is performing the research is related to the approach that we want to have to this evolved scenario of the energy domain, and including the distributed networks that are affected to some revolutions, are changing the role, are getting more and more distributed, and are getting new players. And the one that we are experimenting and exploring is the cooperation that we can achieve between this the owner of the grid, that is the classic approach on the grid management, and new third-party decentralized players that are operating in the grid and can play a outstanding role in the grid management, balancing, and so on. The customers are part of these players that are getting more relevance in the operation inside the grid, and we are tackling these aspects of how to involve the customer, how to involve them with effective role in the dynamic of the program, and how we can design the demand response program in order to have them involved in the proper way. And the final approach, the final context is having a look to the flexibility market, that are still some evolution in the market, is still not liquid. In some cases it could be unfair. So we are trying to understand which kind of services and how to design those services in order to have those flexibility assets operating in a system that can exploit their capability to manage congestion, balancing, and so on. And then the way to involve the players, we are exploring and understanding which are the best strategies, and use drivers like price or incentive, or different kind of drivers that can bring them actively in the process. The tool eDREAM project concept is to provide a tool set, so a collection of set of tools that can support different kind of players, different kind of actors in the value chain, with services and with procedure and methodologies. We collect this in this big picture that is assuming that we start, for example, for demand response pre-assessment using drones that can detect potential players, and we have also deep neural network based estimation in order to understand which are the flexibility potentialities, and then those are provided to the aggregator for the actual provision of services facilitating the district management. Then there are the services for the distributor that are conceived as a decision supporting tool in order to give them enhanced visualization or aggregated data and provide them flexibility and consumption forecast and estimation in order to give them suggestion in how to operate the grid. The blockchain is exploited in order to provide a marketplace, a secure and trustable and fair marketplace where the smart contracts are used to code the agreement among the different players, and also the flexibility management is performed in the blockchain. And then we have also activities related to the estimation of PV plant flexibility, understanding also which are the potential degradation that the infrastructure can have during their time life. In terms of business case and use cases related to the business scenario, we identified three macro use cases. The one is related to the prosumer demand response flexibility aggregation that is performed via smart contract. Then we have the energy trading market that is considered as a local trading in order to have this energy exchange in the energy communities. And then the third one is related to virtual power plant provided in terms of communities that are collaborating to provide typical virtual power plant services. In terms of those use cases considered as part of the eDREAM ecosystem, we have identified those local flexibility marketplace that is specifically devoted to DSO and aggregators, and the energy marketplace is including and involving prosumers and aggregators, and the VPP dynamic coalition. This coalition optimized collaboration of different providers. It's more for aggregator, and this is overall comprehensive offer that eDREAM is providing as a result of the overall program of research. The different use cases are under validation in different pilots. We have Italy, UK, and Greece with 3 different pilots that have focused their validation and experimentation in the different use cases that we just saw. And now we are in the phase where we are collecting the validation result in order to approach the end of the project and shaping and tidying in the final result that will allow us to have the exploitation, the further steps toward the next phases of our activities. The project website is a landing page where you can find main information, mainly detailed information. Today you will receive an overview of some aspects of the project. For any kind of in-depth analysis, we have also the long list of public deliverables that you can find in the website, and then today we are there to give you face-to-face, even if virtual, but face-to-face first description and first reply to your questions. I don't know if there are questions on this, or Madalena?
I don't see any questions right now. I think that we can move to the next presentation.
Okay, thank you.
The eDREAM questionnaire for business models validation. Giuseppe Mastandrea from Energy at Work.
Yeah, thank you, Madalena. Good morning, everyone. I'm Giuseppe Mastandrea from Energy at Work, and in today telco, I will provide for the first intervention a brief introduction of the questionnaire that we have prepared to collect feedback after this webinar. In particular, as you can see in this slide, we have prepared a questionnaire in a Google form, and
Giuseppe, sorry for interrupting you. We don't see your screen.
Sorry.
Okay.
You can see my screen now?
Yes.
Okay, perfect. As said previously, we have prepared a questionnaire to collect feedback after this webinar, in particular through the use of Google Form. The main aim of this questionnaire is to assess the applicability of the eDREAM context-specific business models in the foreseen European country. In particular, we will ask for the background of participant and the interest for the eDREAM solution that we are going to present in this webinar in order to put in relation this information for our statistical analysis. We will ask also for a comparison with similar solution and services if you know some of them, and support for the identification of the barriers related to the business development of the typology of solution as we are as the solution that we are going to propose with the eDREAM project. After that, finally, we will ask also for the evaluation of the core services of our proposal, our system, in particular for the services for the pre-assessment to evaluate demand response services application, the services to support demand response flexibility for prosumers and aggregator, and also the services developed exploit blockchain-based algorithms and peer-to-peer energy trading paradigm. In particular, after this webinar, you can go at this link through our website, in which is present direct link in the page dedicated to this webinar. As you can see, the questionnaire report questions as already described. We can proceed with the introduction of the first business scenarios.
Yes.
The first business scenario is related to demand response flexibility services for prosumers and aggregators. In particular, in these scenarios, the prosumers are enrolled with aggregators. Thanks to a preliminary assessment of each customer, the aggregators is able to evaluate keep updated the general flexibility capacity of his portfolio, exploiting novel techniques and technologies that we are going to present in this webinar. They could know in particular the flexibility available through current and forecasted data from power production and load demands. Through the use of the core services of the eDREAM platform, the aggregator can establish a mechanism to aggregate flexibility and to detect in near real time the amount of flexibility provided by each of the prosumer. The aggregation of the flexibility potential provided by multiple prosumers and the management of the individual deviation will avoid grid congestion, providing a service for DSO. In particular, the DSO, after the identification of day-ahead or intraday potential issues on the grid, such as congestion or reverse power flow, could send flexibility requests to the aggregator through the marketplace based on the received flexibility request. The aggregator is able to inquire its role at the prosumer to identify the subset which may deliver the expected flexibility, creating an offer on the marketplace for the DSO. The aggregator is able also to measure the deviation among the prosumer actual energy consumption and expected profile for the demand response event. And in case of significant deviations, is able to enroll other prosumer. We have provided, we are going to provide description for 4 main core services able to support this process. And I leave the floor to the presenter for technical presentations.
Thank you, Giuseppe. Yes, we will start with the core service 1, demand response aerial survey toolkit. I think that Fatih from TISA University is going to present, or from CERT.
Good morning, Madalena, everyone. This is Paschalis from CERT. I believe for this one, it would be our honor to present a small demo for this
great.
real toolkit. Okay.
Thank you.
Give me a moment. Okay, let me share my screen. So what we are about to see is a small video demonstrating the process of how from optical and thermal images of a building and processing the required data, basically we are able to identify the assets on this building. And beginning with the video, we can see that you can see my screen. Is that correct?
Yes, I can see.
Yes. Okay. Yes. Perfect. Okay. So we can see that we have 2 type of cameras, one optical and one infrared, mounted on a drone. That gradually it takes images of a building. In that particular case, we can see the smart home located within CERT premises in northern Greece, near Thessaloniki. And we can see here that the optical image and here the thermal view of the smart home. And from the optical image, the input is fed in the deep features component, where various parts of the picture are identified, such as ground, the building itself, openings, background, air, etc., atmosphere. And then the output from that component is fed into the next component, where the building mask is detected and isolated from the rest of the picture in order to capture the building itself and make sure that, yes, please.
Sorry, I think you stopped sharing the screen. I can.
Okay.
Or something happened.
Okay, no problem at all. I believe we are here. Allow. Do you? Okay, so I don't know from which slide. Anyway, I think we can go. From this moment on.
Yes, Paschalis, we can see.
Perfect. Thank you. Okay, so after identifying the several classes of this image, several categories, the building mask is detected and isolated in order to focus on analyzing data from that particular location of the image, and in order to identify the assets on that building, and not only the assets but also the footprint from the building, as we can see here, with the use of the infrared camera and the building detection mask, where from the whole picture only the building is analyzed in order to in order to provide as an outcome any thermal statistics such as heat losses, etc., etc. We can see here several thermal values. Apart from the energy footprint of the building, as a building itself, we can see here with the photovoltaic detection mask component that uses as input the building detection mask and the temperature output. And this component is used in order to locate and identify assets as the photovoltaic. In that particular case, the video just ended. Let me just pause it here. So we can see here that in the rooftop here, we can see with our own eyes several photovoltaics. There are also photovoltaics at the back. That's why they have been detected here as well, even though they are not part of the building. But that seems to be an outlier. That's why we see them coming and going in these several images. In any case, we can say that the photovoltaic is located and with great accuracy, one might add, and this will help to locate the assets in a building, and moreover, also the surface of the photovoltaics is also calculated, not presented here, of course, but it's the outcome provided by this tool. So that's all from my side. Any questions from anyone?
Thank you, Pascalis.
Thank you.
So far, I don't see any questions in the chat. So I think that we can move to the next presentation, and maybe some questions will rise later. So we'll move to the core service number 2, big data clustering for load profiling and customer segmentation. Javier Gomez from Atos will present you.
Yeah, thanks, Madalena. Hope you are hearing me, and I think I share my camera too. Yeah, my name is Javier Gomez from Atos, and today I would like to share with you a little video that demonstrates the capabilities of the big data clustering tools that we have prepared. So let just me share my screen. Hopefully you are seeing it right now. I'm gonna play the video, and please interrupt me if you can't hear the comments or the voice. This video is oriented to demonstrate the capabilities of the big data clustering, load profiling, and customer segmentation tools. These tools have been developed in the scope of the eDREAM project. This big data layer is divided into 3 different services, which are the load profiling tool, the big data clustering, and the customer segmentation tool. However, the data pipeline is much more complex and requires several stages to deliver valuable results. During the eDREAM project, we have collected anonymized data from more than 500 users. Unfortunately, this raw data must be pre-processed before we can fit our algorithms with them. This data pre-processing comprehends, as we will see, the tasks of data cleaning and filtering, identify and remove outliers, and finally, locate and extrapolate missing values. Once the data is ready, we can pass them to the load profiling tool. This tool is capable of calculating up to 11 different load profiles depending on the selected model. Just as an example, option 1 will calculate a daily profile with 15 minutes granularity. Regarding clustering tools, we have developed and implemented a self-supervising deep learning algorithm. The neural network architecture is based on an autoencoder model, but on top of it, we defined and added a new clustering layer. After the training stage, which is needed in all machine learning models, the tool shall group the users in the number of clusters previously defined by the operator. In this particular case, the selected number is 4. The customer segmentation tool is a supervised deep learning algorithm that can classify new users into the previously calculated clusters. After training the tool, it can offer pretty good results, scoring an average accuracy of more than 95%. The tools presented until now are backend oriented and designed to support machine-to-machine communications. However, these functionalities can also be requested through a REST API. In this first example, we are requesting to the clustering tool to clusterize the whole dataset based on daily profiles. Or another example, this time clustering weekly profiles Monday to Sunday and using k-means instead of the autoencoder as the clustering algorithm. This final example of the clustering tool is a little bit different. This time we are requesting it to cluster not the user's demand, but their flexibility. So we select the 11th option and, once again, the k-means algorithm. Finally, we can also limit the clustering to a specific time frame. To finalize this demo, we will simulate that we want to classify a couple of new users into the previously defined clusters. So, we send to the customer segmentation tool the user's ID and the time frame. The algorithm answers back with the cluster level of each user. We can see that the different users are classified into two different clusters. Okay, so that was the video. Thank you very much for your attention, and I give you the floor back, Madalena.
Thank you, Javier. If there are any questions so far, if not, we can move to the next presentation. Core Service 3, Demand Response Service Optimization. And I will let Fatih Abuhem from Teesside University to present.
Yeah, hello everyone. I'm going to present one of the core components of the eDREAM projects, which is demand response optimization. I'm going to share my screen now. Hello everyone and welcome to this webinar. My name is Fatih Abukshem, Research Associate at Teesside University. In this webinar, I'm going to present the decision-making and DR optimization toolset developed by Teesside University within the eDREAM project activities. The decision-making and DR optimization toolset is one of the core components.
Sorry, Fatih, if you could please turn off your microphone.
The main functionality of the decision-making and DR optimization toolset is to provide the aggregators and energy retailers with toolset that enables them to utilize their energy resources in an optimal way. In recent years, the transforming of traditional power systems from centralized electrical power generation plants operated by large utilities toward clusters of distributed generation networks has received a great deal of attention by the power providers over the globe. These distributed generation networks are termed as virtual power plants. Virtual power plant is defined as a network of decentralized medium-scale energy generation units treated like one single power plant. The units aggregated on the virtual power plant can be wind turbines, solar systems, and combined heat and power units, as well as flexibility offered by prosumers participating on the DR programs. The toolset consists of two main models: decision-making model and virtual power plant optimization engine. The decision-making model provides the virtual power plant managers with the optimal amount of the power reserve that is needed to balance the fluctuation comes from the renewable energy resources and the flexibility provided by the DR programs. Once the power reserve has been calculated, the virtual power plant optimization engine will provide the virtual power plant managers with the optimal dispatchable schedule of the generation units participating on the virtual power plant. The output of the engine will be the optimal list of generation units which should be used and the set points of each selected units, which satisfies the power demand and the power reserve. The general structure of the toolset is as shown in this figure. The tool uses the output from other components of eDREAM platform. These components are prosumer's consumption production forecast, prosumer's flexibility forecast, prosumer's baseline estimations, and historical data related to the prosumers from database, as well as dispatchable generator data, which is also from the database. These data are used by the tool to first estimate the uncertainty of the PV generation forecasts and the uncertainty of the flexibility estimation, then make decision for the reserve and do the optimization. The output of the tool will be optimal scheduling of the dispatchable generators, aggregated virtual power plant PV power generation forecast, and aggregated virtual power plant flexibility estimations. For the uncertainty of the PV generation forecasts, the forecasts obtained from the production forecast component are deterministic, which means only a single value in each target hour is provided. Thus, the tool, and based on the historical PV generation data and past forecast data, calculates the forecast error and estimates the prediction intervals. For the uncertainty of the flexibility estimation, the upper and lower bounds of the flexibility of each prosumer are obtained from the flexibility estimation component. Using these limits and the baseline estimation, the tool estimates the flexibility of the VPP and its prediction intervals. Based on the uncertainty analysis of PV generation forecast and flexibility estimation and the risk index selected by the operator, the decision-making module will calculate the power reserve, which then used by the optimization. The idea of the optimization is that the optimization algorithm will select the optimal set of generators which generate the required demand, and also able to ramp up and down to balance the variations of the PV generations and flexibility provided by DR programs. The optimization problem is formulated as a customized unit commitment and economic load dispatch problem, and the objective is to minimize the fuel cost, where in unit commitment optimization, the operation schedule of the dispatchable generator is evaluated, which means identifying which generation unit will be on and which will be off. Then in economic load dispatch optimization, the set points of these units are calculated, as the independent variables of unit commitment are discrete and the independent variables of the economic load dispatch problem are continuous, and algorithms which can deal with both kinds of variables is needed. Or we might use two different algorithms, one to solve unit commitment and another one to solve economic load dispatch problem. To solve the optimization problem, a series of optimization mechanisms based on GenOpt optimization program and the method of Lagrange multipliers and priority lists were developed. GenOpt is a generic optimization program developed by Lawrence Berkeley National Laboratory, University of California. GenOpt has a library of various optimization algorithms such as generalized pattern search, particle swarm optimization, hybrid global optimization. However, not all algorithms of the GenOpt program are able to solve problems include both discrete and continuous variables. For this reason, and to use the full capability of the GenOpt, another two optimization methods has been implemented. Lagrange multipliers, which is used to solve the economic load dispatch problem, and used with the GenOpt algorithms which can solve problems with discrete variables. The other method is the priority list, which is used to solve the unit commitment problem, and used with the GenOpt algorithms which can solve problems with continuous variables. A user interface works as a supervisory program that controls the operation of the optimization engine was developed. The interface also provides a user-friendly environment to use the GenOpt program, which is not present with the current versions of the GenOpt software. One of the main objectives of the user interface is to create an algorithm selection framework that acts as a decision support system to help the operators to take the most advantage of the GenOpt program. In the remaining time of the presentation, I'm going to run a quick demonstration of the toolset. We start the optimization by selecting the method. We have three options to choose, either GenOpt, priority list GenOpt, or GenOpt Lagrangian method. If we choose GenOpt to solve the optimization problem, this means that the GenOpt will be used to solve both unit commitment and economic load dispatch problems. In this case, only the algorithms which is able to solve problems with mixed, discrete, and continuous independent variables will be enabled. If we change the selection to priority list GenOpt method, Then only the algorithms which is able to solve problems with continuous independent variables will be enabled. Once the optimization algorithm is selected, its configuration and settings will be uploaded. These settings can be easily amended and changed by the user. After selecting the method and the optimization algorithm, we need to upload the data. 5 files need to be uploaded. Generators data, loss coefficient of these generators, demand curve, flexibility estimation of the prosumers participating on this VBB, BFE forecast data, and historical BFE production data. To start the optimization, we press Start Optimization button. The general program will start. It will generate the independent variables, send it to the model, and reads the value of the objective function. Once this completed, the cost and set point of each generator at each time slot will be displayed. The output of the optimization engine is shown in this screen. On each time slot, the power demand, the minimum cost achieved by this algorithm, and the set points of the generators are shown. The results also are presented graphically on the user interface. At each time slot, the set points of each generator and the cost are presented. And that is the end of the presentation of the decision-making and DR optimization toolset. I have presented its objectives, structure, and demonstrated its functionality. Thank you for listening.
Thank you, Fatih. Do you want to add something more, or we can move to the next presentation? I think that the connection is not very good. So we will move to the last core service of this section. Interactive visualization based on graph analytics for a decision support system. So I will give the floor again to Pascalis from CERT.
Thank you, Magdalena. Let me just share my screen again. We're going to another video. Let me just... No, here we are. Perfect. Do you see the screen? Is everything okay?
Yes, Pascalis.
Okay, perfect. Thank you, Giuseppe. So, what we're about to see here is a small video presenting the visualization platform for 2 out of the 3 actors contemplated in the eDREAM framework of in the project. That is the consumer, as we can see here, and the aggregator. Here we can see that from this visualization platform, the prosumer can set the parameters of the consumption in a friendly way. That is, he can provide whenever illuminance settings and temperature settings are available in order to set the constraints for the thermal and optical comfort within the premises, within the household, and also set the desired temperatures for the HVAC or set points, and also several devices if they're about to be included in the next DR events or not. Here there is also the option to be opt-in or opt-out entirely as a facility, as a house from any upcoming DR events. And following, we can see here the aggregator view, starting with several KPIs to be shown for each individual users, here anonymized of course, and trying to compare between them or among them in order to identify which user is has more potential in terms of demand flexibility, energy consumption, and CO2 reduction, as we can see here in the Kvyat diagram in this chart here. Here we can see the aggregator choosing among four users, four users among the whole portfolio. And here he can choose other metrics such as the min max or the average values of the portfolio as a whole, and to compare these users with these statistic values for a particular timestamp, as we can see here. And of course, there are other views, such as this one, with clustering among the users on the portfolio, where you can see here that it's highlighted in all three tabs, where we have energy consumption, energy generation, and in the middle we have the consumption minus the generation. That is, we call it merged. And we can see how through this clustering is usually in all clustering techniques, how the users are related to each other among all these three KPIs. And finally, we have the DR aerial survey management panel, where using the input from the DR aerial survey toolkit that we have seen earlier, here the output of that particular tool, as we said, we have identified the PVs, any other assets that are available from the building, and the energy footprint of that building in order to identify its potential regarding flexibility, for example, in an upcoming DR event. And here we have that particular information provided to the aggregator, where he or she can see it and have a more hands-on knowledge on the matter. So here we have used again shared premises, where we have actually surveyed two buildings, the ITI building here and the smart home located here down and on the right. We can see also the energy class, the surface of the building, date of scan, and we can see here as well any other features such as the assets, current temperature, wind speed, etc. And of course, we can see also the video that has been related to the survey, and also the video that presents the building in order for the aggregator to have a better view. That's all from my side. Thank you for your attention. Any questions?
Thank you, Pascalis. So now that we have seen which are the core services of this section, Giuseppe will present the associated business models of these services. And then we will have the Q&A session.
Yes. Thank you, Madalina. Can you see my screen?
Yes, yes, yes.
In presentation mode, yes. Could you confirm?
Yes, in presentation mode.
Okay, we are going to summarize what we have presented with, from the technical point of view. providing brief business models based on Canvas methods for these first business scenarios. Considering that eDREAM is a RIA project, one of the key partners needed to bring the solution to the market are the investors. And then the other partners that could act as key partners in our business are the partners that are the natural beneficiary of the solution, such as the aggregators, the energy communities, and also the balance services providers and DSOs for the resolution of the problems related to the grid congestions and so on. The key activities to bring to the market the solution are mostly related to the accomplishment of minimum viable product ready for the market. Precisely for the reasons the investors are needed, a future development of prototype is needed to launch the solution to the market. To this end, also is needed a marketing startup campaign by using tools such as logo, brand, visual identity, and so on. It's very important also the creation of international sales network, the capital rising, and the creation of an advisory board with top-level profiles in order to monitor also the solution, and the management of IPR, in particular to, for example, the creation of a joint venture between the project partners with the aim of protecting the common commercial interests and the intellectual property of the results achieved. As regards the value proposition, as shown, the solution the main proposal of solution is to provide advancing the demand response optimization and flexibility management tool to optimal manage the clusters of flexibility sources, and user profiling, to improve also the management of the renewable energy system as flexible asset, and also our system is able to provide a benefit from the environmental point of view. The relationship with customer could happen in real time through a web-based customer service, to also technical assistance on site, also as regarding the pre-assessment services and so on. And we can expect also to provide reward mechanisms for customer loyalty. The customer segments identified are composed mainly by the actors that could benefit from our platform, that are the aggregators, balance service providers, and energy retailers. The key resources are, as said, as shown during the technical presentation, the core elements of our platform, such as the tools for pre-assessment, to also the usage of aerial survey toolkit, the instrument for load and user profiling based on big data clustering and customer segmentation, service for the optimization of demand response, and also the advanced platform to manage all of these services. More important is also the human resources. In fact, the know-how gained is able to provide a competitive advantage respect the other competitor. For instance, thanks to the possibility for R&D department to gain continuous improvement for the solution, and also important for the legal department for the definition of innovative contractual forms associated to our proposal. As regard the cost, we have considered CapEx and OpEx cost. CapEx is related to the cost necessary for the development of a minimum viable product and maintain stable its delivery on the market. And the OpEx are associated to operational costs for the commercialization of the solution, particular costs related to the management of legal, administrative, sales, costs related to the management of infrastructure costs, and so on. We have also identified with the aggregators present in our consortium, in particular with Kiwi Power, the channels for the exploitation and commercialization of the solution that are related mainly to direct sale of the platform to the customers through perpetual or monthly software license, and also the revenue streams that could exploit the actual organization that is based on platform licensing, monthly or perpetual, and revenue from asset nodes setup and configuration, for example, pays as a service. Madalina, I think that we can have a question and answer session or move to the other presentation.
Okay. So if you have any questions regarding the tools that were presented so far, you can address them directly using your microphone or using your chat. I will share my screen to show you the chat section where you can find it. So if you can see my screen, the chat section is here on the right side on this icon. So here you can write any questions if you want. Okay. And Pascalis, if you could turn off the microphone.
Yes, sorry for that.
Don't worry. Okay, so it seems that there are no questions right now. And I think we can move to the second section of the webinar, eDREAM business models on local peer-to-peer energy trading. Giuseppe will provide us a short introduction, and then Tudor Ciora from Technical University of Cluj-Napoca will present three core services: electricity consumption, production forecasting, blockchain-based decentralized control, and price-driven flexibility market, and the last one, peer-to-peer market and financial settlement. So Giuseppe, if you could tell us a few words, and then we can move to the service presentation.
Madalina, can you see my screen in presentation mode?
Yes.
Perfect. Okay, we are going to present the second business model of our meeting, and that we have developed in our project. In particular, I will going to introduce the local peer-to-peer energy trading services that we have developed in our project. And after that, as said previously by Madalina, Professor Tudo Choara will provide the technical details and demonstration of the developments, the eDREAM developments on this topic. In particular, the peer-to-peer electricity trading is a very innovative business case. It is based on an interconnected platform that serves as an online marketplace where consumers and producers meet to trade electricity directly without the need of intermediary. In general, a platform is able to allow locally distributed energy generators to sell their electricity at a desired price to consumers willing to pay that price. The electricity is usually transacted between users that could act as buyers and sellers in the platform. In general, the users could also become members of the platform, for example, for instance, by paying a predetermined monthly subscription fee. In particular, in eDREAM case, the developed platform is able to enable any prosumer or energy player to trade energy in peer-to-peer fashion and in an automatic way by using of smart contract to a platform managed by market operator to regulate bids and offers, identify the settlement prices, and trace the transaction. In particular, the visioned energy marketplace is able to enable any local prosumer to directly participate in a market auction. This market make use of smart contract to implement in a programmatic manner the peer-to-peer energy trading between prosumers and consumers. The smart contracts are distributed at the level of the peer with the prosumer enrolled in the marketplace and stipulating the expected energy production demand levels, energy prices, incentives for the rewarding of prosumers consuming the renewable energy when available. During a market session, each prosumer can submit bids and offers representing the amount of energy they are willing to buy or sell. And the surplus of energy could be used also to provide ancillary services to the main grid operators. I give the floor to Tudo Choara that will present the 3 core services related to this business model about electricity consumption and production forecasting and peer-to-peer market and blockchain-based decentralized control and price-driven flexibility market.
Hello, so I will try to share my screen. Okay, so I will start with a short introduction on the technical aspects and the components that are facilitating the implementation of business models based on local peer-to-peer energy trading. More specifically, these business models are enabled by 3 core services that are developed in the eDREAM project. The first services is the electricity consumption and production forecasting, and this forecasting is done at different level of granularities, at individual prosumer level, but also on more aggregated level at aggregator level or community level. The second core service is the blockchain-based decentralized control and price-driven flexibility, which enables the sale in a peer-to-peer fashion of available flexibility in a microgrid. And the third core service is the peer-to-peer energy market, which enables the peer-to-peer trading of energy. The first core service that deals with electricity production and consumption forecasting. The aim is to provide and to enable an accurate prediction of available energy demand, generation, and flexibility. In this case, we have addressed different time granularities. So we have implemented day-ahead forecasting, which is the forecast for the next 24 hours, intraday forecast, which aims to improve the results of the day ahead by having a shorter and more closer to the real-time time frame, which is 4 hours ahead, and intraday and 1 hour ahead forecasting to have a better view what happens in near to the real time. The solution for forecasting is based on machine learning. More specifically, we have constructed a tool that is able to do an assembly between individuals, weak learners, with the goal of optimizing the forecasting process and reducing the uncertainty. As features of the learning process, we have used energy-based features, which are based on the logged energy consumption of individual assets, but also we have considered contextual features, so features that are not particularly related to the energy consumption, to the energy value, but influence this energy value, like seasonality, years, days of the weeks, weekends, and so on. An innovative aspect of this service is that beside the demand and generation forecasting, it is able to forecast the flexibility. By flexibility, we refer to the ability of a prosumer to alter its energy demand in relation to the baseline. So how much the prosumer is able to increase its energy demand or to decrease its energy demand in relation to the baseline, where the baseline represents the regular energy demand profile of specific prosumers. Based on these models, we have created a forecasting tool and service, and using this forecasting tool, we have obtained good reliability results for different aspects of energy forecasting in all the three pilots of the eDREAM project. The results being influenced and are directly influenced by the quality of the monitor data and also by the quantity and how much data is available for that specific pilot or specific prosumers. The second core service is targets the decentralized management of flexibility. And the decentralized management of flexibility, it can be done in two ways. The first way is done in a decentralized fashion using smart contracts, and the second way by implementing a price-driven flexibility market. The underlying technology of both options is distributed energy ledger that is based on blockchain. It's a ledger that is implemented in the eDREAM project specifically to store in a scalable and efficient manner energy data, in particular energy transaction of individual prosumers. This blockchain ledger combines different technologies such as NoSQL databases with a distributed queuing system with the view of increasing the scalability and in terms of energy transaction throughput and cost of the reducing the cost of the transaction in terms of gas. Also, because the privacy of energy data is really important, a specific solution based on zero knowledge proofs have been developed and integrated to assure the privacy of energy data. On top, we have implemented smart contracts that are able to control and aggregate in a decentralized fashion available flexibility of the individual prosumers. And in this case, the aggregation is done by directly injecting girl curves into the smart contracts regulating each individual prosumer behavior, allowing in this way the aggregators to aggregate the necessary flexibility. And moreover, the blockchain technology enables the near real-time monitoring of the delivered flexibility, bringing the settlement process more closer to the real time. The second option is to trade flexibility in a peer-to-peer fashion. In this case, in the local marketplace, the main actors are the flexibility buyers and flexibility sellers. An important aspect in implementing this market is the tokenization and digitization of energy flexibility. In this case, we have used non-fungible tokens to represent and quantify the available flexibility that could be traded. And using smart contracts, we have defined smart contracts for buying, selling flexibility, and managing the trade. The main
Tutor, sorry for interrupting. I no longer see your presentation. I don't know if something...
I don't know. I will share it again.
Okay, thanks. Just to make sure that...
Okay, so the main benefits of deploying such a market at the microgrid level are the fact that in this way, using and trading energy flexibility, we are able to increase the usage of locally produced renewable energy. We are able to minimize the exchange between the local grid and the main grid, and also we empower communities to take over and contribute to the management of the local infrastructure, aiming to allow them to act as much as possible as a microgrid island that is targeting towards self-consumption and energy autarky. The interaction between the smart contracts are represented in this picture. So we have smart contracts that are that allow prosumers to register with the market, to trade, buy or sell flexibility, and also we have smart contracts that are managing the market, so are managing the session of the market and conduct the delivery settlement. Also, the delivery settlement being brought closer to the real time due to the near real-time dissemination of information provided by the blockchain technology. Finally, the third service is the peer-to-peer energy market. In this case, the asset that is traded is the energy. The tokens in this case represent the amount of renewable energy that it's being produced in the specific microgrid. And using this tokenization, we are able to to allow prosumers, in this case generators, to sell in a peer-to-peer fashion its energy production to the local consumers. At the same time, also smart contracts are being developed, allowing the submission of bids and offers, and also allowing the matching of the bids and the offers, and settlement of energy transactions in near real time. Okay, so this was my presentation. I also have a small video showing the peer-to-peer, the price-driven energy flexibility market. Just a second to try to share it somehow. Do you see the video?
No, only the folder with the video.
Okay. Let me try to share it in another way. Okay. I think now you are able to see it.
Yes.
So this video was recorded in the context of Terni pilot. So using data collected from Terni prosumers, we have implemented this price-driven flexibility market. In this flexibility market, there are several roles. First of all, there is the role of the prosumers. The prosumer can log into the platform. The prosumer can choose various aspects that you want to trade. Maybe the prosumer want to trade its electricity. Maybe you want to participate in a decentralized control of flexibility. But in this case, the prosumer selects to go on the price-driven flexibility market. In this case, it will be displayed with the previous session bids and offers submitted and the reference price for the previous day, in order to have a better view of how its offer should be formed. Here we can see the flexibility forecasting, which is facilitated by the flexibility tool. In this case, the prosumer can see the flexibility forecasted, allowing him to understand what is the level of flexibility that the prosumer will be able to trade in the next market section. Based on this flexibility potential, the prosumer will be able to submit offers on the blockchain. The offers and will be registered as energy transaction onto the blockchain, and during delivery, using the live monitor data of individual prosumers, we are able via blockchain to trade the actual to monitor the actual energy consumption. And moreover, what is more important, we are able to trade the delta differences between what it has promised in the flexibility transactions, in the flexibility trade, and what it's actually delivering. And this is important for bringing the settlement process closer to the near real time. This will allow third-party stakeholders to understand in advance the prosumers that are not conforming in specific demand response programs, and they are able to intervene and select potentially other assets to provide the difference of flexibility not delivered. The second role is the role of the aggregator. As an example, if the aggregator goes into a price-driven flexibility market, it will have both roles. So the aggregator could buy the flexibility of individual prosumers, smaller scale prosumers, in order to sell it to other markets, to other stakeholders like the DSO, but at the same time, the aggregator could be a provider of flexibility and could sell some of the aggregated flexibility through other platforms. In this case, the aggregator could see a similar view of the previous session of the market. Also, the aggregator could see the state of the grid, and based on this information, it will be empowered to submit bids and offers onto the flexibility markets, which are again mined in the blockchain system, making them tamper-proof and paving the ways towards delivery, tracking, and eventually settlement. During the delivery and the actual delivery, based on the monitor data, in this case the aggregator, it is able to track and monitor the flexibility delivered by each individual prosumers from each the aggregator had bought flexibility. So in this case, he can track this, and also he can it is empowered to select other sources of flexibility if some prosumers are not delivering as promised or what is expected. The third role is the market operator role. In this case, the market operator could see what happens during a market session, flexibility market session. He can see the bids and offer registered and committed in transactions. He can check the matching graph between the bids and offers, the peer-to-peer matching between individual prosumers that are trading flexibility. And also it can check the whole delivery of flexibility in that particular into that particular microgrid, and how the differences in delivery of flexibilities are being balanced. Okay, this is all from my side. If you have any questions.
Thank you, Tudor.
Thank you.
Okay, I think that we can move to the presentation of the business models, and then we will conclude with the final discussion and a Q&A session.
Okay. Can you see my screen?
Yes.
Presentation mode?
Yes.
Okay, perfect. Okay, the most part of the business model, considering that are very related business scenario, are quite similar, because are both very innovative proposal, and both of them need, for example, for investors, for activities related to the accomplishment of a minimum viable product, the starting of a marketing campaign, the creation of international sales network, as already said, activities for capital rising and so on. Despite this, going to the key partners, we can see that the prosumers and consumers, as the main actors involved directly in the activities of this scenario, are a very important key partner. also the energy communities as communities of prosumers and consumers. But for this case, the legal and regulatory practitioner, the energy market regulators, market operator are very important because regulation is needed for retail market, for example, to enable trade of power among prosumers and consumers without renewable generation capacity, to establish regulation on data collection and access of this data, the security, the privacy aspect for the platform, and also the relation with the peers that take part in the activities of the platform, to define a role and responsibilities for all the stakeholders involved, to ensure that consumer rights are respected by these stakeholders in the peer-to-peer action, to define market operation rules for the peer-to-peer schemas implementation and distributed at level of distribution network, to enable also, for example, the DSO to procure flexibility from this type of schema, defining technical criteria for the application of ancillary services, but also to support these initiatives by implementation of policies that are able to encourage decentralization of power systems and also the better utilization of existing grid infrastructure in this sense, to encourage also the actual pilot programs to work as a test bed for this type of schema, and also to improve the access, as said previously, for the capital for the development of this type of platform. As value proposition coming from the application of this type of solution, we have indicated the peer-to-peer exchange of energy surplus between peers via the online platform in a decentralized mode over the network, and also the transaction without intermediary, and by using innovative instrument as the smart contract that could enable also the automatically transaction for energy. In particular, the possibility to sell renewable energy between the market participant directly or indirectly. Also the possibility for the prosumer to be independent from the classical historical operator. And we have indicated between all the option, the environmental benefit to the promotion of a local, efficient, and sustainable renewable energy consumption. The relationship with the customer happen through the self-service platform, and as indicated for the previous scenario, also to real-time web-based customer services and providing also technical assistance. Most important aspect is the empowerment of consumers and active engagement in energy demand supplies on the local energy market. Customer segments are represented by buyers and sellers of energy, the prosumers and the consumers, the energy communities, and also the actor that could benefit from the surplus of the energy, such as balance service provider and energy retailers. The key resources are constituted mainly from the key resources indicated for the previous business model, in particular from the core services already presented, and human resources, financial resources, and ICT infrastructure. The channel. The channel for the dissemination of this type of solution are constituted from the penetration through national and local energy community networks. The energy community networks could be the main actor to involve, to engage, for a real implementation of this type of solution, and the virtual energy exchange market where peers are able to trade their energy products. As indicated previously, we have indicated in our business model a list of CapEx and OpEx costs, and as for revenue streams, are constituted mainly by the commission fees for the transactions, and the possibility to have a peer-to-peer gold membership for energy communities. If there are any questions, I think, Madalina, we can start with the question and answer session.
Okay, thank you, Giuseppe. So with this, we are concluding the presentations. Now, if you have any questions, you can ask them in the chat section or directly. We will be happy to answer them. Also, if the presenters or the project coordinator would like to add something about the project, feel free to do it. So we will wait a little bit to see if there are some questions from the attendees.
Yes, this is Vincenzo. We would like to give a summary about this today webinar. This is we presented the different activities that we performed during the research project. This is a collection of activities that we are going to consolidate and finalize, considering that in June officially the project is going to be concluded, and so we will have results of the project as a consolidated assets, consolidated technological assets, and as part of activity of different partners, we are going in some case to extend the experimentation with other projects we already established, or we are going to establish collaboration for the future activities. And so these aspects of involving local community and ESO and aggregators and this kind of new scenario is something that we will continue to explore, and we already have let's say a program as collection of projects that are going to carry on in these activities. So I don't know if in the audience there are questions related to other projects or other details related to the tools that were showed and described in a brief.
So far, no, I don't see any questions.
Okay. I don't know, Madalina. I think if there are no questions, we can first thanks everybody for participating to this webinar. The information on the project are available, and we are actively disseminating the project results. So we are actively participating to liaison with other projects. If you think that any kind of result can there is one question related
Yes.
to cost saving.
Which are the cost-saving implementation blockchain in trading energy? Are some examples, historical data?
Okay, actually I told you that the evaluation is going to be concluded, and as part of this evaluation, we have one deliverable that is going to collect all the different pilots performing, and also those KPI in terms of performance KPI are going to be compared with the costs that we had to tackle per pilot case. The pilots are our reference, the one that we actually put in place the solution. I have to say that at this moment we have no final data, no final figures about this kind of ratio between performance and costs, but it's going to be published in a public deliverable. And Fatih, I don't know if you want to give some details about the deliverable that will be available probably after the summer. Fatih, are you connected? No, probably there's a problem of connection. But in
Yes.
any case, I think we are still working on those figures, so we have no final numbers for this kind of comparison. In terms of pure technical KPI performance, Giuseppe, I don't know if we already have document collecting the KPIs in terms of technical KPI. We could provide them the reference. We could provide to the audience the reference to the deliverables where those results are published. Okay, Fatih, please. No, I heard something. I thought he was maybe he's trying to recover.
Yeah, I think that he's trying to connect, but maybe he has some
Yeah.
problems. Mhm.
Okay. From the pilot side, do we have some initial numbers about or Giuseppe, do we have initial numbers related to the technical KPI performance in the pilot sites?
Well,
Hello, can you hear me now?
Okay, Fatih, now you are connected.
Yeah, so sorry. So I have to leave and joined again. So I don't know what's going on. So with my mic. So anyway, so as you've said, we are in a stage of collecting this data from the pilot sites and from the other partners. Some of the KPIs has been sent to us, but the other ones is still being calculated. So it is at this stage, it is not really ready to be announced. But as I said, this is, maybe within 2 weeks or less, so the report will be ready probably.
yes, Vincenzo, to also answer to your other question. The cost analysis is something that has to include several factors. So as Fatih said, it's something that is still being finalized. But on the technical side, on the other hand, we already have analyzed some preliminary results, and even if the document is not finalized yet, our results show that, for example, the performance are not affected in comparison with a traditional database based system, and so the blockchain doesn't affect negatively the performance because it's used as a second layer. And for example, the objective of the DSO in terms of benefits from the flexibility can be achieved easily, but not yet on the cost side. We don't have this figure as you said.
Yeah, we have to remark that we are not leveraging on any kind of public blockchain. So mechanisms like proof of work are not used in the project. So this kind of let's say high consumption mechanism are not included in our process. We are considering private blockchain with the concept of having some certain level of trustness between the different stakeholders that are taking part of the value chain. So we also examined some potential extension of just restricted set of data that could be stored in the blockchain, but this is something like minimal considered with the high volume of meters data and value transaction that we handle inside the ecosystem platform. So essentially, we have the classic high energy consumption impact that some blockchain usage can determine. Okay.
Okay.
Yeah, Gabriel, I hope we gave you some elements related to your question.
Yes, yes, Vincenzo. Thank you. Thank you very much for your for all this information. Very interesting. Thank you.
Thank you. I don't know if there are other questions. I don't see in the chat. No, maybe they are not.
No.
Okay, Madalena, what do you think? Okay.
Yeah, just a few words before ending the webinar. We highly appreciate if you could take 2 minutes of your time and fill in the questionnaire that we have prepared. Maybe Giuseppe will provide the link in the section chat so you can have access to it. And you also receive a follow-up email with a link with the webinar recording if you like to watch it or share it with other people. Okay, so on behalf of eDREAM Project Consortium, I'd like to thank you for joining us today and have a great rest of your day.
Thank you, everybody. Have a nice day.